Here comes the third in my telescope viewing or telescope videos. I would just had made two videos about this small 80mm refractor. What I'm going to do is show you something here that I just discovered. I should have known better. On the original I showed you that handle was going down toward the eyepiece. I found out that handle blocks the ability of the telescope to aim high up in the sky. So what I did is just rotate the telescope tube around on the thing by tripod by 180 degrees. Now that handle sticks upward. That clamps the altitude control. Now you can see the telescope was almost aimed straight up. You have to sort of fit it in between the tripod legs like that, and you can aim almost overhead in the sky with it without any problem at all. You just have to, it's unbalanced quite a bit, so you have to make sure this clamp is really tight when you release it. And another thing is that the telescope itself comes this little plastic plug right here. You can put in, and that'll keep the dust out of your telescope when you don't have an eyepiece in it. Just a little, and it's got a warning there on it telling you not to look at the sun with the telescope, which is good. You have to have a special filter right up here. And this spot right here, you have to have a filter right where that lens cap is, over the top of the telescope tube objective lens, in order to safely look at the sun with a telescope. You really can't do it. Look at the sun safely unless you have a special filter there. It's a good idea not to have a finder scope that's unmasked either. You have to make sure that you can't look at the sun through your finder scope, because you could easily blind yourself that way. And what I do when I'm looking at the sun sometimes with a filter is I just move the telescope around until the shadow of the tube is a nice circle on the ground, and then the telescope is usually aimed fairly accurate at the sun. You don't have to look through the telescope initially to aim the telescope. Aim the tube at the sun, but you have to have that filter in place. Another thing too is that one reason I wanted this telescope is because it can use an eyepiece. I give you an example. I own a 32mm focal length Astrotech Plössl eyepiece, which is a nice eyepiece, and it doesn't cost very much, and it has a 50-degree apparent field of view. And with this telescope right here, the magnification is 20 power, which is approximately the same magnification as a high-power pair of binoculars. So what happens then is it makes it much easier to aim the telescope, because the actual field of view in the sky is 2.5 degrees wide, which is approximately 5 times the width of the full moon. So you have a very wide field in the sky with this telescope at low power, and it makes it very easy to point the thing at the moon or any other object. You just have to point it in the approximate direction, and maybe even sight along the top of the telescope tube. Get your eye down about here and just sight along the top of the telescope tube and along the side of it and the top of it, and you can aim the thing within a degree or two by that way. And with that wide angle eyepiece in place, you can actually aim the telescope pretty easily. And not only that, but if you're looking overhead in the sky, it's awful hard to get your eye underneath that finder unless you have a mirror there. You could put a little tiny mirror there if you wanted to help you aim it overhead with the red dot finder amongst the background stars. But the field of view with the low power eyepiece in this thing is so wide, you could actually aim the telescope just by sitting on the stool. And look, you might have to, of course, extend the telescope legs up a little bit, because you could see the eyepiece is pretty close to the ground when you're aiming overhead. So you might have to extend the telescope legs to the full extent, and maybe even the central column you might have to raise up a little bit down. All you do is undo that little thing right there, that little knob right there where my finger is, and then you can just raise the central column by pulling it straight up and then clamping that. It makes the telescope a little less sturdy because you've got that extra little thing that could wobble around, but you can actually get the telescope up quite a bit higher by a lot of tripods have little cranks, but you really don't need that. All you have to do is undo that, pull it up, and then clamp it with your other hand, and you can extend the telescope, the height of the thing, up almost 12 inches by doing that. So but you can see there's an extra set of feet down there. I don't know whether you can see very well. There's an extra set of feet. This has 4 sections to the legs on this tripod instead of the usual 3. Okay, so it works very well that way. Now, let's see, what else was I thinking of? Oh yeah, I mentioned the Beta turret, where you can, but you could actually swivel this telescope around And if you know the constellations and star patterns you're looking for, you really don't need to look along the telescope tube. Sometimes you can actually just while you're actually looking through the eyepiece, you can sweep the telescope around manually. Aiming overhead in the sky is a good idea. Kind of clamp that, and then swivel it sideways back and forth, and sweep around for what you're looking for. And actually look while you're doing it. Get sort of a panoramic sweeping view, and then if you're a little lower high, you can clamp it in azimuth, and then in altitude you can unclamp that, and while you're looking through it you can kind of shift it up and down a bit if you want. But there's ways of getting around having to get down underneath that finder and look through it, because this telescope has such a wide field of view at low power that it almost serves as its own finder scope. So it's really pretty neat. Okay, now I'm going to shift on to the next thing I'm going to talk about, and that is my C5 Celestron Planetary telescope. I'm going to give you a little bit of view of that. I've got it over located about here, and I bought this actually as a spotting scope on Amazon at a very good price. They seem to have it on sale. It was I could tell you the price. It was actually $543 in Canadian dollars, and that included free shipping to my house. So all I had to do is pay the sales tax on it, which brought it to approximately 600 Canadian dollars. Now, what it did was, this telescope is a 5-inch Schmidt-Cassegrain telescope, and right now I've got it mounted on a really good Orion lightweight tripod. It's got a simulated fluid head in it. It doesn't have an actual fluid head, but it's actually pretty good. It's very smooth. That little tripod right over there is almost as smooth as this tripod is, and that one right over there, it only cost me $40, including shipping charges, so it's pretty good. This one right here is a Schmidt-Cassegrain, like it's a 5-inch. The telescope tube weighs about 6 pounds without an eyepiece in it, and with the spotting scope designation, it came with a 45-degree diagonal mirror. It was actually in the form of a prism, which is pretty good. But for my purposes, for sometimes when you want to look overhead in the sky, it's better to have the 90-degree diagonal. So what I did was put this diagonal right here, that little diagonal right there, that's a mirror in there. It's a 90-degree diagonal. As you can see, the eyepiece comes out at a 90-degree angle from the main telescope direction, just like it does with the refractor. And that diagonal has a 99% reflecting enhanced coating on it, so it's really pretty good. I got that from Orion, and as you can see, it clamps the eyepiece in there just like the other diagonal. And you can also, just like the refractor, it's got a set screw right here and a set screw right down there, and by doing those you can actually tilt this diagonal up and down that way to get a comfortable observing location when you're sitting on the stool. And this right here, you could see the logo on it if I can get it close. I'll try and hold the camera really steady. I don't think it'll autofocus close enough for you to see that very well. But that is a 9mm focal length TMB planetary eyepiece with a 58-degree apparent field of view. And the images stay sharp, almost, if you're looking at the planets or the moon. The images are extremely sharp in that eyepiece over the whole field of view, almost out to the very edge. It's just amazing eyepiece. And it's also a fairly long eye relief. This has approximately 15 millimeters of eye relief, which means you don't have to get your eye too close to the eyepiece in an uncomfortable location to look through it. And this eyepiece right here gives approximately 140 power with this telescope. And I've had views of the planets and the moon with this summer that were just absolutely breathtaking. Saturn was so clear that it almost seemed surreal. The rings were just amazing, and the moon craters and the mountains on the moon were just spectacular beyond belief. Just absolutely amazing with this telescope. This arrangement for this telescope, the way it's clamped onto the tripod, is almost identical to the small refractor, except for the fact that I made a homemade slow motion control, and I'll show you that. It's got a spring right there, as you can see. It's a tension spring, which means it tends. There's a pair of hinges right there that I'll show you, right side by side. They're just ordinary door hinges. You could buy at any hardware store or Walmart or someplace like that, or Canadian Tire. And they allow these two plates to spread apart, and in very smooth manner. The hinges, I had to line those hinges up very carefully so that there was no binding on them or anything like that, and no wobble. And then what you do is, if you want to move the telescope up and down in small motions, what you do is get your telescope aimed generally in the right direction by undoing this thing here, and then the telescope shifts up and down in large amounts, and you have to be really careful because the telescope is highly unbalanced. You have to hold on to it really good with the right hand, where you move it up and down and then clamp it with that when you get it in the right spot. But the tripod is really sturdy, and it clamps it really securely in that spot. And then you can also shift it around in azimuth, that's the horizontal motion, by undoing that, and it'll swivel around in a very smooth motion because it's a simulated fluid head. And what was I thinking of? Oh yeah, then usually I leave this undone, like loosened up when I'm using it, but I always have to remember to clamp that fairly tight when I'm carrying the telescope around, because the telescope flops all over the place sideways when you carry it if it's loose. So you have to make sure everything's clamped when you're actually carrying it. I'll show you how this works. The altitude control, I think you can see it all right from that angle. You turn this, this is just an ordinary piece of 3/8" threaded rod, and there's a coupling nut in there you can see right there. It's a 3/8" coupling nut, and it's held in there with JB Weld, which is a really high quality epoxy glue, right into the wood. And you just turn that bolt like that, and that moves up, that spreads the plates farther apart or closer together. If you turn it this direction, the spring tends to pull the plates closer together, and it allows you to, and this bolt right here, the tip of it is rounded by a file, and I think you can see it right there. It bears against a metal plate. You can see the metal plate right there. It's a thick metal, sheet metal plate, and it's glued onto that plywood with JB Weld. And so you can, it's amazingly smooth. In actual practice, you can lower and raise this in very small amounts, which allows you to aim the telescope very precisely in altitude. And for moving it in azimuth, as the Earth rotates, the azimuth motion sideways, back and forth, is very smooth too. So it's pretty easy to, once you get a planet or a star or the moon in there, it's very easy to track it. Of course, it's not an equatorial mount, so the planet is moving constantly through the field of view, and you have to keep, you can look at it for maybe about 2 minutes with a high power eyepiece like that, and then you have to shift the telescope again in position. But this whole thing, the tripod, the telescope tube, and everything weighs approximately 11.5 pounds. Just a little bit more than 11 pounds with a lightweight eyepiece in it, which is still pretty heavy, but it's a lot better than carrying a 23 or 24 pound telescope on an equatorial mount with all the clock drive and stuff on it, or the counterweights on it. This weighs approximately half or less than the same telescope mounted on a lightweight equatorial mount. The difference is quite profound when you're trying to carry it around at night, with one hand especially, in and out the door. So this right here is actually a little camera case I bought, and that holds 2 or 3 extra eyepieces. You can just, they're tucked right in here. I'll see if I can show you one that's in there. I think there's one right in there now. There's one in the top layer too. Hold on, it's a little hard to get undone. I'm getting to the end of my video production. I think there's a spare, yep, there's a spare eyepiece right in there, you can see it. So it's easy to take them in and out at night. And when they're in there, it actually, pardon me, I have to do this zipper up again right here. There it goes, and there's a top compartment. If the eyepieces are not too big and heavy, it'll hold 2 there, and you can reach in either side, and there's no danger of you getting your fingerprints on the lens of the eyepiece. You can kind of grip it from the side. You have to be careful of it. This is just tied on with butcher twine, like a heavy-duty form of string. I'm going to make a better way of fastening it. I have this clamped onto the altitude clamp. This is a crank that you use to raise it up and down in altitude, and I don't use that very much, so I just use that to help to tie the thing on. And it's getting toward the end now, so I'm going to cut this one off and start another one going.